Alright, half-life is the time that's required for half of the material to undergo radioactive decay, which means half of it will be gone. So the equation that you're going to use is that the fraction that remains is equal to 1/2 to the n power, and n is the number of half-lives. So the question is it true to say that it only takes 2 half-lives for any material to be gone? Because a half-life is time it takes for half of it to be gone. So if you had 2 of them, would all of it be gone? And the answer to that is no. We can see from the graph, if I start out with 16 grams, then after 1 half-life, I would be left with 8 grams. After another half-life, I would have half of that 8 left, which would be 4. And after another half-life, half of that would be gone, which would be 2. So you can see that each time it gets cut in half, but I never go to 0. So in this problem we start with 16 grams of a radioactive isotope and want to know how much will be left after 3 half-lives. So we can use our equation that says that the fraction that's remaining is equal to 1/2 to the n power. And n is the number of half-lives, in this case 3. So I would take 1/2 to the 3rd power, which means I have to take a half times a half times a half, and a half times a half would be a 4th, times another half would be an 1/8. So I would have 1/8 of the 16 grams that I started with remaining. So 16 times an 1/8 would be 2 grams is how much I would have left. So 2 grams is how much I would have left. And that's how you're going to solve a half-life problem.